here we are going to start a new course on signal and systems, and before starting I want to clarify that this course is very fundamental course. So you don't need any specific prerequisite to understand the concept embedded in this course, and you just need to have some basic idea of calculus and complex number from your mathematics background, and these two topics will suffice all the concepts. If any new terminologies will come, I'll explain accordingly. To start with, signal system is basically used in electrical engineering. It's very well known term, but the concept and techniques that forms the core of the subjects are of fundamental importance in all engineering domains. And the domains include wide areas like biomedical engineering, communication, or aerospace engineering, etc. And also, the area is expanding as the engineers are confronted with new challenges. That makes this course of utmost importance. So, before going in depth of the coursework and discuss all the topics we will discuss in this course, we have to first understand why we are studying this subject and what these two terms means. So, we'll understand what signal and system means. So, let's move on. To start with, signal basically contains information about the behavior or nature of some phenomena. So there are various physical phenomena occurring in nature. So signal contains information about those phenomena. And what system does? System basically respond to particular signals by producing other signals. So it's basically a response kind of thing. So signal will be processed by system and produce some output signal. So it's kind of a black box which take input as signals and produces output signals. And the output signal can be in a desired manner depending upon what the system specifications are. And we'll discuss more in details when we further discuss about systems. So now we'll see some examples to understand these two terminologies very well. So basically in electrical engineering we always deal with circuits. So circuit is an example of system, and voltages and currents are form of signals. There are other examples as well, like the camera which you use to take pictures. It's an example of classic example of systems. What it does, it will take input from light reflected from an object and produces picture of it. So it's also an example of system. And not only these are very tiny examples of signal system. There are n number of examples, and we will see further like how we can relate the widespread area of engineering with these two terminologies. The wide area of science and technology, just to give some examples, are communication, biomedical engineering, circuit design, speech processing, etc. Now, once we get an idea or glimpse of what signal and system means, we can move on to the next thing, that is the context in which we are studying this subject. Like what are the important question and problem we are going to target using these two terminologies or this course. So basically there are two kind of problem, that is first is analysis and second is synthesis. So analysis, what does analysis means? So suppose we have a specific system and we are interested in characterizing it. So we have a system and we want to characterize it. How we can do it is called analysis of that system. So what we'll do, basically I'll give you just brief idea. We'll pick the system, we'll throw various inputs to that system, and we'll get the corresponding response or output of that input. And by recording these we can characterize that system. So that system can be characterized. Now the next context is synthesis of the system. So what we'll do, we'll design a system in this manner. So what we wanted to do, we wanted a signal which is in a particular form must be converted to some desired form. For example, suppose we have an image which is very noisy, so it's a noisy image, and we want some clearer form of it, so clear image here. So how we'll design that system to get a clear image from a noisy image? So in this manner we will synthesize that system. So these are the problem which we are going to address through this course. Now these are all the theoretical concepts. We have discussed about the physical phenomena, how the signal contains its information, what are systems. But to deal with mathematically, we want to represent those physical phenomena in some form. So there are various applications. So in some application the signal can vary continuously in time, whereas in some their evolution is described only at discrete point of time. So to give an example, the speech signal, like what we are talking right now, I am talking, and that is considered as a speech signal. So that is continuous in nature. But suppose we are wanted to study about the stock market and how it behaves. So basically what we do, we record every day the nature of the stock market. So it's a kind of everyday recording. Suppose sometime it's high, sometime it's low. So it's a kind of discrete nature. So we are recording at discrete points. Every day we are recording, so that's a discrete point. So some signals are discrete in nature. So this will lead to our next topic, which we are going to discuss in brief and which lay the foundation of this subject and we'll use throughout in this course. These are continuous time signals and discrete time signals that we will discuss in our next lecture. Thank you.